Welcome to the WineDown, an afternoon podcast where two techie blokes sit down over a bowl of wine and chat about what's happening in the world of tech. Enjoy while Scott and Nick open up about their week in technology.
Well, hello and welcome back to the WineDown. My name's Nick Beaujard and with me I've got
Scott.
Hey, and today is our 21st episode of the Weekly WineDown. Yay!
Yay for us.
So, Scott, where are we? What are we not drinking to celebrate our 21st?
Well, we're not drinking just yet. We are back in our office, just because all the gear happens to be set up here, and inherently we're a bit lazy. So, but...
Speak for yourself.
Each their own, I suppose. We actually have a nice little bottle of champers.
Nice.
And I thought I'd... well, actually, no, I can't. Actually, I can call this champers. It's French. Champagne being a trademark of France.
Yes, the Champagne region.
Yeah,
it must come from the region.
yes.
Otherwise, it's just Méthode Champenoise.
Or was it Australian white sparkling?
Yeah, Australian white sparkling. That will do.
Bubbles.
Yes.
So this bottle was actually interesting in that we tried its, I'll say its cousin, although really it's probably its stepbrother or stepsister. The previous vintage of this, and it's not actually a vintage, it's because it hasn't got a year. It's a Baron de Rothberg wine, and it actually mimicked Verve.
As in Verve Clicker.
Verve Clicker. Yeah. It actually tasted a lot like that. It was like, oh, that's really interesting. So we actually thought that, wow, and strangely enough, it was like $20 or something like that. We thought, oh, wow, that's someone's in trouble now. So we bought a case of that, and only to find out that
Didn't taste like Verve anymore?
No, it didn't. So it was actually the next production run that we had that came out of the winery, and lo and behold, it just doesn't taste like Verve anymore. So I don't know what's going on there.
Oh, well, never mind. Anyway, champagne for our 21st.
Yes.
So, Scott, we've just spent a three-part series talking about Wi-Fi. We're going to continue on the network vein.
Yes, on the wireless vein.
On the wireless vein.
Well, actually, true wireless in this context.
Excellent. So, all of this stuff we're talking about primarily is used to deliver this thing called, with a capital I, the Internet.
The Internet. Actually, it's no longer with a capital I.
Oh, get out of here. I had to do an exam saying it was capital I.
It used to be, and the Oxford, they've actually declared that it is such prevalent use now, it is no longer a capitalised noun, it is a lowercase I for internet.
Internet, lowercase, used to be your internal internet, and internet, capital I, used to be the internet, but they've changed all that.
They have.
Awesome.
So now we're off track.
So anyway, but the internet's something that it's a global tool. People are now saying it's a right. You have a right to access. They have a right to power and fresh water. You should have a right to internet access. So it's a global tool, but it's not everywhere, is it?
It's not everywhere just yet.
Okay, so
soon to be.
Soon to be. Well, we're going to talk about that in this session. So here in Australia, we've got, and we're not going to, one day we'll do one on the NBN, but we're not going to talk too much about the Australia's national broadband network, because it's not necessarily the most successful broadband network in the world. It got a little bit politicised on the way through.
I think as per a lot of good intentions plus politics equals average outcome. Maybe, I don't know. It's getting there. I do like the idea of where it was supposed to be heading, but look, let's take that a step aside.
So it's a mix. They've got the multi-technology mix. Now, I know at home I have fibre all the way into my home. Fibre to the premise. And the node.
Yes.
There's always a bit of fibre there, isn't there? Even if they're really doing it with copper.
Yes.
But there's people who don't have a cable connection at all, do they?
That's right. So you've got HFC, the hybrid fibre coax connection, which is using the old cable TV last mile
cable TV thing. Yep.
Yeah. But then you've got Wi-Fi, which is point-to-point wireless,
right?
Where, or I should say, point-to-multipoint. I think in a lot of cases where you're actually using a dish on a roof on a premises and pointing it out to a tower somewhere where you've actually got usually line of sight Wi-Fi.
Yep. Okay.
That's a percentage of the population there, and that's good because it actually gets you coverage where there's no cabling or no fibre in the ground.
Understood. But we've also got satellite, haven't we?
Then there's satellite. So when you start to get to places like regional, rural Australia, where it's not just not just that the fibre is not close, and someone's put a Wi-Fi tower up to be able to do that. We've actually gone to the next stage of there's no fibre nearby, there's no copper nearby, there's no Wi-Fi nearby, there's nothing there.
There's no power. It's just a tent in the middle of the desert, and then we can deliver something using satellite.
Yeah, so we're using satellites. So NBN has gone with the Skymaster satellites. There's 2 of them.
Yep.
They sit in orbit, and you basically point a dish up, and you get a wireless internet signal.
Are they geostationary, or do they?
They are geostationary.
So they're quite high. They're geostationary is a long way above the Earth.
They're about 36,000 odd kilometres up in the sky.
Wow. Now, if I remember my maths correctly, radio waves travel at roughly the speed of light, depending on the medium they're travelling through.
That's true, depending on what they're travelling through.
And so that's 3 times 10 to the 8 metres per second.
Yes.
And going that kind of distance takes some time.
It does.
Measurable time.
It does. And if you think about this, we're using satellites plan for about 100,000 businesses. We're about 1.5% of the population as far as the target NBN goes.
Wow, that's quite a lot to be using something with that high latency, right?
Well, you've got some islands as well, like Cocos Keeling, Christmas Island, that sort of, and this is how satellite is being how internet is being delivered to those islands.
I always thought satellite was traditionally high latency, and by high latency I mean you send some data, it's got to go all the way up to the satellite.
It does.
And it's got to come all the way back down, and the laws of physics say that won't happen instantly, and that's sometimes 300, 400 milliseconds to do that round trip.
A good trip is about 300 milliseconds up, and then 300 milliseconds back down for the response.
And that's for geostationary satellites like Skymaster.
Yes.
Wow. But it's traditionally low speed as well.
So the current NBN satellite plans are either 12 meg down, 1 meg up, or 25 meg down, 5 meg up. But you don't really get all of that, and it is contended. Because I can tell you that for $100 odd a month or whatever it is, that doesn't actually cover the cost of a dedicated 12 meg down, 1 meg up satellite.
So it's expensive too.
Yes.
Okay, so they're 36,000 Ks in orbit.
They are.
There's 2 satellites. Now, the bandwidth to those satellites, what they're capable in total is...
But both of them is about 135 gigabits per second, full capacity, like flat track.
Okay, so divide that by 100,000, and you've got 1.35
megabits per second. Assuming everyone was transmitting at the same time. Look, it's actually not that bad, because contention says you're never going to have everyone transmitting at the same time, so you've always got other capacity available.
Unless we decide we're all going to stream... I don't know. Some Netflix all at the same time, or a
4K Netflix stream,
or we want to all watch a stream of Scott Morrison announcing a new telehealth program over the NBN or some such thing.
What you mean in the regional areas where they're likely to actually watch that sort of thing for where the satellite is?
I don't know, maybe, but
no,
yes.
This is it. It's where when you get those sorts of things, some of the areas that are serviced by satellite are the ones most likely to be using the high capacity.
So let's talk a little bit about latency, because latency. I think people don't understand the difference between bandwidth and latency.
Right.
You can have a high latency connection with enormous bandwidth.
Yes.
You can have a low latency connection with almost no bandwidth, and both of them are bad.
Yes.
But they're bad for different things.
So think about this. If I were to send a package to, let's say, to Trevor, who we know, who is in Melbourne, and we are here in Sydney, I could put that on a plane.
Yep.
And that plane would hold so many packages, which would be the capacity. And the plane goes really fast, in theory.
Yes. Yeah, okay.
Or I could stick it on a camel.
Yep.
Or on let's just say a big truck that a camel is pulling. And I know that in 5 days, the camel's going to get to the other end.
Yep.
But there's a lot of capacity in there.
Okay.
But it's really slow to get to the other end, and it's really slow to come back.
Okay, so a plane, because it's expensive, has low carrying capacity, but it's low latency because it's quicker.
Yeah.
Lower latency.
Lower latency.
And your camel, which apparently can carry more than a plane, we're just gonna I'm gonna let this I'll let this one flow all the way through, Scott. The camel's worse. So yes, but they're worse for different things.
They are.
So we did an experiment when I used to do some work in South Africa, where we sent data from South Africa to Namibia over the Telkom network.
Ah, yes.
And then we sent the same amount of data in the mail on a USB stick.
Right.
And the USB stick got there first.
Yes.
because the bandwidth was so small,
Yes.
although there wasn't much latency on the line, it's hard to fit a football down a garden hose. So that means if you're streaming, you don't really care about latency, you care about bandwidth,
That's
right?
I think your analogy is better, by the way.
Okay. you don't if you're watching TV online, you don't care if that's 10 minutes later than it was broadcast. That's irrelevant.
That's right.
But if you're trying to have a video conference,
Oh, absolutely.
people will notice just over a 200 millisecond delay. They'll get annoyed with a 600 millisecond delay, and a 1,000 millisecond delay will just wind them up totally.
Yes.
Same if you're doing remote control of a screen. Same if you're playing games.
Yes.
So anything that requires you to interact with the person on the other end of the line, big latency is no good. Anything is you consuming content or uploading something to a web server, and that's fine. Latency doesn't matter, bandwidth matters. So that's kind of, does that work as a difference between the two? Better than the camel and the plane?
Perhaps.
Okay. Cool. So, Skymaster, we're kind of saying not great bandwidth and really painful latency.
Yes, but that is satellite, and it's not saying that there's different brands that will be better. This is the physics that are involved.
You cannot change the laws of physics, Jim.
That's right.
Hey, I wondered when I get that in. It is the 21st episode. I could do stuff like that. So we've got a laws of physics issue. We can't break the speed of light yet.
Yeah, that's right.
Yeah, I don't think you're allowed to.
These are global issues. So every country's got this. Every provider's got this. If you're using satellite, it is what it is.
But we've taken these Skymaster satellites. So satellites traditionally been very expensive, very big, very hard to put somewhere. We stick them in geostationary orbit, so they don't move. So I can only need to put a couple up, and I can cover Australia. But they're really high, and the latency is really high. There's something else where the International Space Station's in something called low Earth orbit.
LEO, low Earth orbit.
Okay.
This is very interesting.
Now, is anybody doing internet stuff in low Earth orbit?
Funny you should mention that.
Oh, yeah, so I've got notes in front of me, Scott. It's not hard to work out what we're going to say next, is it?
So, SpaceX, which is the Elon Musk rocket ships going
Just
up.
tied for second richest person in the world. He just tied with Bill Gates.
That's interesting.
Yes, there you go. Yes.
There you go. They've actually created a company called Starlink. And what they're doing is they're putting satellites up into low Earth orbit, which is, in their case, 550 kilometers up in the atmosphere.
Okay, so let's compare this. We were talking about Skymaster being 36,000 kilometers up, and these are just 550 kilometers up.
That's right. Now, when you think about that, there's some good and bad points about this. If you think that here's the Earth and you've got these satellites 36,000 kilometres up, they can see a lot from that height.
Yep.
So they've got a lot of coverage distance.
They do, but it's still only an eighth of the distance from Sydney to Perth.
Correct.
Look at me go. That's not bad mental arithmetic for today, is it?
So you're saying the distance from Sydney to Perth, 8 times that distance is where the satellite is up in the sky?
No, the distance from Sydney to Perth is like 4,000 kilometres, isn't it?
So about 8 times that.
So, 550 kilometres versus 4,000.
Okay.
It's an eighth of it.
So I'm talking about the NBN satellite.
Oh, no, I'm talking about the SpaceX ones.
This is good. We can do maths. Okay. So if you think about the NBN with Skymaster, there's 2 satellites 36,000 kilometres up. They can see a lot of the country from up there, and that's why there's 2 of them covering the whole country.
Yep.
When you get to 550 kilometres up, you can't cover that entire country area just from there very effectively.
Okay, so you're going to need more sats.
You need more satellites, but because they're closer to the ground, the latency problem is addressed in a big way.
Wow. Oh, boy, you can tell. 550k versus 36,000.
Yeah, it's about 70 times better.
Yeah. Okay. We like 70 times better. That's cool.
So what we had been seeing was about 600 milliseconds in latency going to the satellite and so forth.
Yep.
Comes down to about 30 to 35 milliseconds or so.
That's cool, but we need more satellites, don't we?
We need more satellites.
We need a lot more satellites.
So what's happened so far is, and this was, there's a bit behind this, because this isn't just let's put some satellites in orbit. This is actually creating commercial workloads to support launching the rockets.
Yep. Okay.
Otherwise, the rockets would be going up, and they go, well, that's good, but no one's paying us to send rockets up with nothing in it. So this is actually a business model to support needing the rockets, which actually funds other programs and so forth.
Wow. Cool.
Having said that, they've had about 1,440 by the end of which is end of next year, 1,440 satellites will be in orbit, in low Earth orbit,
Right.
in various places around the globe.
But they got way more approved, haven't they?
They've had 12,000 approved so far,
Whoa.
and they've asked for another 30,000.
That's a lot of satellites.
That's a lot of, and look, it's a lot of, I'll say space junk. It's not junk, but that's a lot of stuff floating around up there. And keep in mind, these Starlink's not the first company to send something into orbit.
No, there's lots of stuff up there. There's even, I don't know if you played Kerbal Space Program, but there's a thing called the Kessler Syndrome, where when you have one satellite that, say, hits another one and they explode into space debris, there is the possibility that will create a cascading ripple effect, and then we'll never be able to leave the surface of the planet again.
There you go. I did not know that.
Yeah, there we go.
And probably never come across it again.
Yeah, let's not do that anyway.
But they're sending up 60 at a time.
Yep.
In those rockets.
And there was a launch just back a couple of weeks on the 25th of November.
There was. There was actually one. Yeah, the 25th of November being
a couple of weeks ago.
Right.
Yes.
Okay. So, in those connections, we're seeing the initial test connections are about 150 megabits per second download speed at, say, 30 plus milliseconds latency.
Okay, so we're comparing that for 25 megabits to 150 megabits with latency way down. So bandwidth's gone up, latency's gone down. Both good things.
All of a sudden, it's a viable option.
Yep, cool.
And so it's quite interesting to see where this is heading. Now, there's actually not quite enough satellites up there yet. This is very early days.
Yep.
The satellites are not geostationary.
No.
Meaning that you'll never have the same satellite above you continuously. They do move around. But having said that, when you connect to one and you get out of range, you then connect to the next one.
Sure.
There's not enough of them yet to really provide seamless coverage everywhere. That's okay.
But they're going to get there, right?
They're getting there. This is work in progress. But it's very interesting what they've done, what they've achieved so far.
That is interesting, but they're going into space is big.
Yes.
Actually, if you listen to the Hitchhiker's Guide to the Galaxy, it's very big.
That's a brilliant observation.
But Earth orbit isn't so big. So what? There's lots of stuff up there, right? For everything from Apollo bits to Sputnik bits. Sputnik burnt up, but there's all sorts of junk up there.
So we actually worked out. And the numbers are varied depending on what you call an object.
Okay, so they're not counting the flecks of paint travelling at 30,000 kilometres a second, which would...
But I've seen there's actually about 25,000 inactive objects floating around out in space. There's actually upwards of 500,000 objects less than 10 centimetres across.
Well, but these things are going super fast, right? An impact from one of those is huge.
Yeah, and look, and this is even with the Starlink satellites. The idea is that they only have a lifespan of so long. They're about 260 odd kilograms or something each. They're mass produced
and
very cost effectively.
Run out of fuel, and they're going to sit up there.
Well, actually, no, they're not, because now it's a bit like when you want to do some landscaping or build a new house. You've actually got to have a plan that says, what are you going to do with the old stuff that's on the site? How are you going to environmentally friendly remove it?
Oh, so they're going to deorbit them at the end of their life and burn them up in the atmosphere.
Yeah, the idea is these are cheap. Get them up there, use them when their lifespan runs out. I don't know what that lifespan is, but when the lifespan runs out, turn them off and just let them sit back into the atmosphere and drop down, and eventually they'll just burn up in the atmosphere and they're done.
Cool. Awesome. So is any international group looking after this kind of stuff?
So I didn't know this. I actually found the United Nations have an Office for Outer Space Affairs.
Well, America's got Space Force. Well, I don't see there's a problem with that.
Somehow I don't think it's the same thing. But they actually have a register online, and they are tracking, at the moment, 10,093 items, including what country sent them up and what the declared use was at the time.
Okay, yes. Well, we won't go into all that horrible science military stuff.
But I guess there's two parts. That one says that, oh look, someone's actually it's like you have to put an application. I want to do this and I'm going to send this thing up, and they say, okay, we'll add you to the register. The other thing is, if you don't say what it's going to be used for, who knows what you're doing, or it assumes that everyone actually lists.
So 150 megs, 30 milliseconds latency, not for me, right? I've got 5G if I'm near that, or I've got fiber into my home, which is running at a gig.
Yes.
So who's going to use it, Scott?
Okay, so if you've got, let's just say you're going to have, of course, your residential and business areas that traditionally haven't got the coverage.
Yep.
And those areas, for example, in regional Australia that were trying to do, let's say, telemedicine or something like that.
Yep.
That really haven't got that good satellite coverage, all of a sudden have got access to these sorts of speeds. you've also got the next stage of this being other countries that have traditionally not got the infrastructure in place.
Oh, so Africa and bits of
Look,
Middle East and-
developing countries. Like we used to have one of our sales guys used to go to Nepal a lot.
Yep.
And just liked it over there. And every now and then he'd actually take some Wi-Fi gear over there because there was no fibre.
Sure.
And you'd find that this hill would have a little village somewhere on it, and they'd want to talk to that village over there, and there's no copper, there's no fibre, there's no anything, so they'd actually go and put a couple of Wi-Fi units and beam them across and start building networks that way.
So also US regions, because the US is big.
The US actually has terrible internet outside the major cities. I mean, we sort of hear that, look, it's cheap, it's fast, it's whatever. It is depending on where you are, but as soon as you get into the regional US, it is atrocious.
Okay, because everything's driven by money there. There's
it is.
Let's do things for the betterment of our society stuff.
And in fact, that's how Starlink are getting access to fund a lot of this through funding for the US regional areas from the government. Yes, to deliver that.
Now, but it's not just residential. People can start building corporate networks over this, can't they? And that gets quite interesting.
It does. So look, here's where this is heading. Let's say that you've got a site in Sydney and a site in London. Now, traditionally over fibre, that is about a 300 millisecond round trip time, give or take. And look, it is what it is. We're again, the laws of physics. What we're seeing, though, and this is based on where the fibre runs, you can actually, for example, send a signal up to your low Earth orbit satellite. The satellite then, via laser, talks to another satellite, which talks to another satellite, and very quickly beams a service down to the other end.
Okay, because it doesn't have to do full, and even if it did full curvature of the Earth, it's going absolutely straight line, whereas when we run fibre, we've got to go around bays and valleys and cross oceans.
And so that's, and the other thing is, if you're thinking about how do I run fibre, I've got to go and dig a trench, put the fibre in, whatever else. Well, here, let's say I want to link from here to London.
Yep.
And I say, hey, London, stick this dish on your roof. We're going to put a dish on the roof. And a few hours later, you've actually got a dedicated link going back at low latency.
That's very cool. That's very cool.
It bypasses all the carrier networks.
Oh, they're not going to like that, are they?
So could you think of any other companies that are producing, that have global cloud offerings and global services that would actually think, well, this wouldn't be too hard to put a few satellites up there and all of a sudden become our own telecommunications carrier?
So we're watching guys like Microsoft think about doing this.
That's an interesting name you've mentioned.
Maybe guys like Amazon thinking of doing this. Maybe, okay. So
and all of a sudden, they're not beholden to the underlying telcos that are saying, you want to have connectivity in this part of the country. Yeah, it's going to cost you a bum.
But it's not, because I'm now running my own satellite network.
Just put a few satellites up in orbit. How hard could it be?
Cool. So
there is a bit to it, by the way.
I get it. That's space and that's the Earth.
Yes.
Right, but we need networks in other places. Can we put a network somewhere else?
We can. This is very interesting. It just sort of came out of the blue, but so NASA's got a moon launch planned for 2024.
They do,
and Nokia just recently was awarded a US $14.4 million contract to put 4G on the moon.
Wow. Is that because their phones are indestructible? I've got to ask.
That must be the black hole in the network where it's here. No, so they actually worked out if they can get 4G. 4G is quite a robust technology. The speeds are pretty good. And they've said, if we can put some towers in various places on the moon, then as the astronauts go off to explore and do their other things, they can just communicate using 4G technology, commonly available.
Wow, cheap. Effective, easy to fix. We know how it works.
And if you're thinking about it, look, $14.4 million for some base stations and a few other things, given that it's actually got to be assembled on the moon and whatever else.
It's got to be hardened for moony stuff, right?
But that's not necessarily an enormous amount of money to set up an entire new telecommunications network in a place that's never had it before.
It is very, very impressive, and in a harsh environment like the moon. So that's kind of cool.
It's not as if there's PowerPoints floating around you can just plug this stuff into. And
So thinking of all this space networking,
yes,
which has been fascinating, Scott, and thank you for that. Is there any message you want to leave everybody?
Our driving message that sort of supports everything that we do. Don't forget to patch.
Make sure everything's updated.
Do your updates. Patch your infrastructure.
And patch everything, even if it's on the moon.
Yes.
Scott, that was awesome. That was very interesting. Thank you for the wind down today.
Thank you very much, Nick.
Now, do remember, guys, if you want to subscribe, there's a link down there. Also, if you're listening to this, you can subscribe on iTunes, Spotify, wherever you get great podcasts. You can also watch us record this on YouTube or look at it on Facebook where we live stream. I hope you've enjoyed today's session. Thank you, Scott.
Thank you, Nick. Thank you, everyone.
Have a great day. See ya.
Bye.